Here we present the GENEA Challenge 2022. This is the second GENEA Challenge, which establishes the state of the art in the field of machine learning-driven gesture generation. So what does gesture generation mean? Gesture generation consists of mapping input speech, represented as audio or text, to a sequence of body movements performed by a character uttering that speech. Research in this field has been ongoing for decades, but crucially there is no proper benchmark for the field. Often, no comparisons are performed between the results produced by different methods, or if comparisons are made, they are often not performed systematically. As a result, it is difficult to determine the state of the art in this field. To address that, we have launched a series of gesture generation challenges, which we call the GENEA Challenge. Our approach is to standardize all the components for evaluating gesture generation, except for the generating systems themselves, to allow for a rigorous comparison of different methods. The dataset is the same for all the challenge participants, as is the visualization pipeline, and the evaluation is standardized as well. The challenge was run in the summer of 2022. 30 teams from all over the world registered for the challenge, and of those, 10 submitted their systems for evaluation. The evaluation featured 4 types of motion sources. The first was natural motion capture from the speakers in our dataset, abbreviated NA. Second and third were existing baseline systems for text and audio based on openly available code, abbreviated BA and BT. Finally, the systems submitted by participating teams, abbreviated as SA through SQ. Now let's get into the challenge results. To begin, shown here are 2 sample clips, one from a challenge system and one from the motion capture.
Yeah, I don't know. They make it as such, but yeah. It's interesting because you don't see those ever, so. Yeah, I don't know. They make it as such, but yeah. It's interesting because you don't see those ever, so.
Surprisingly, while they are different, both clips appear to perform at a similar level of realism. This quality of performance is something we had not seen before this year's challenge, and we'll return to that point shortly. Here we consider the first dimension of our evaluation, specifically human likeness. The evaluation interface we use here is called HEMVIP, which is short for Human Evaluation of Multiple Videos in Parallel. Participants would play one video at a time and give each a rating on a sliding scale between 0 and 100. These are the results. You can see that one of the systems in the challenge, labeled FSA, performed better with our participants than the natural motion capture, labeled FNA. This was a surprising result. We have never before seen artificially generated gestures perform on par with motion capture on a high-fidelity avatar. This indicates a new milestone in the field of gesture generation. In addition, our results show that most of the systems evaluated in the 2022 challenge performed better than previous baselines. The second dimension evaluated in the challenge was appropriateness. This is a measure of how well the gestures appeared to match the corresponding speech. Here we compared the output of each system to a deliberate mismatch. In the mismatched clips, the gestures had been generated for use with a different segment of recorded speech. And so we evaluated how often the participants would prefer the correctly matched version to the mismatched version. Interestingly, the results show that the natural motion, that is, the motion capture, was preferred 75% of the time. Apparently, it is not always obvious which gestures are more appropriate. Furthermore, most of the systems produced results that were barely above random chance, just above 50%. It seems that we are still far from reaching a good level of appropriateness in the generated gestures. This plot shows both human likeness and appropriateness together. Human likeness is shown on the x-axis and appropriateness is shown on the y-axis. Note that the different gesture generation systems do not lie on a diagonal line. This indicates that the correlation between the 2 metrics is now weak. We did this in order to show that we have successfully disentangled naturalness and appropriateness in our evaluation, which previously had been a struggle in this field. So what are the takeaways from the 2022 GENEA Challenge? First, modern gesture generation systems are able to generate movements comparable with those produced from motion capture. Second, generating appropriate motion is far from a solved problem. Third, challenges like this one help move the field forward, and they help establish where the state of the art currently lies. Finally, all the materials from the GENEA Challenge, including code, videos, ratings, and evaluation results, are publicly available for your use. Thank you for watching. Please check out our paper on this subject, the GENEA Challenge 2022, a large evaluation of data-driven co-speech gesture generation, at seed.ea.com.